Hi everyone. Let's talk about problem 39 combination sums. We are gonna we are having an array and a target. We should find all subarrays that their total is gonna be equal to the target. We can repeat an element in how many times that we want. So for example, 2 is 4 plus 3 is 7. It's a distinct integer, so it means we don't have 2 here again. Even if we had it, it was meaningless because we could make it a set, get it distinct, and then we can repeat 2 as many times as we want. Here is it. Now for the solutions. There are different solutions that I'm going to talk about. The first thing that you are going to find mostly on YouTube and everywhere else, which is the most straightforward, even this link is talking about that, is using a path. So here we are going to use backtracking. In backtracking, we are going to give the remaining, the path, and the current sum. At the beginning, what is the remaining? Everything, the array. What is the path so far? Nothing. And what's the current sum? 0. If the current sum is equal target, that's good. We add it to the response. If current sum is more than target, good. We are going to return. Otherwise, that's the main thing. Um, we are going to make a loop. We are going to do a DFS remaining. Remaining would include the I itself because one number can be repeated as many times as we want. Path, we are going to add n. Basically, that's n, I can say. N here, and current sum plus n is going to be here. Okay, I think that's straightforward. One improvement to that would be instead of the remaining, we are going to just send an index. So path is path, the same thing. Index, we are not going to send the whole array. We are going to say the index of that. So here you can see I, and then that's it basically. It's slightly faster than the previous one. The other way to do is dynamic programming. Dynamic programming is faster than the other two. However, the issue is it's going to get too much space. My understanding from this one is for both of these two, or time spaces 2 to power of the target and y target. Okay, because, or how do we get that? Worst case scenario, everything in the remain in the candidate is 1, so it can take 1. So then the answer would be, so if it's like a binary tree, the depth is gonna be m, or target, then 2 to power of target. Okay, this is, as I said, it's faster, but the issue is it takes much more space. We are gonna we are gonna create a DP, dynamic programming, to the array here. We are gonna find out the answer for each number. So we are gonna start from 1, 2, 3, up to the target itself. Okay, for C in candidates, okay. For I in range of C plus C2 target plus 1, we do not need to check before C as there is no answer. We already know about that. So, um, if I is equal to if I equal to C, then we are gonna add the DP. We know that it's gonna be one of the answers. We are gonna add it. And for here, we are gonna say for each combination of array of I minus C, we are gonna add C. And then we are gonna return the last DP. Working. This recursion is also fast. It's faster than it's I think the same speed with dynamic programming. I don't still don't know why this recursion is much faster than these two, but it's faster. And we need to implement that one if we want to get to memoization. Memoization is the fastest one. I'm gonna compare all of them together so you are gonna see. Okay, how this one is working. This one is what I can say real recursive. How does it work? So you have a helper function. What helper function is gonna send us is an array of the answers. First, we are gonna sort everything. It's gonna make it faster. I think even if I sort it here, it's gonna help. We can check that one anyway. So helper, we are gonna give it two things: the candidates and the target. Target, we are gonna start. So we are gonna decrease from the target that we have each time. Okay, so let's start from here. We are gonna say if there is no candidate, okay, or target is minus, just return empty array. We understand. If not, then define res, and then we are gonna say, okay, for all value of the candidates, what we wanna do? We wanna basically, okay, let's forget about these two for now. Let's stick to these two. We are gonna say, okay, we know how we have a candidate, or we have an array, and we have a target. The answer would be we are gonna when we are doing the for loop, it's we should find the target minus candidates I. If we find an array that whose sum is gonna be target minus candidate, and then we are gonna add that one, the candidate to end of that one, or beginning, it could be the other way, then we have to respond. What do I mean by that? Let's say, for example, I'm just saying, we know, or for example, or target was 6 and no candidate I is 2. Then, if we have an answer for target 4, then if we add 2 to answer element, that would be all of the answers. If we do a for loop on answers and add 2, it doesn't matter if it's at the beginning, here, or at the end, then that's going to be the answer. This is what we are doing here. Okay, what we are doing here is also interesting. We are saying if candidate I is target, easy peasy, go and add it. We already know about that. If we are gonna say if I is, okay, we are gonna say if candidate I is equal to candidate I plus 1, continue. We don't need to do that basically because it says there is no duplicate. I don't know why it's doing it, but we don't need to do that. So my understanding is we don't need this line at all. We can just say if this is true, add this one and then do this one. Okay, hopefully that is clear. I can put it there and test it. is wrong here. Yeah. Okay. It's good, good. As I said, we don't need this one. We can make this one just if. Cool. Okay. Don't think this is meaningless, this answer here. 10. Okay, anyway, that's the that's one of the answers. I think that's one of the fastest answer. I don't know why. You see, it's for some reason it's not good. Anyway, we got an idea how it works. Let me go here. Just comment this one out. Comment this one out. Make this one if. Okay, cool. We don't need to do that. I think that is clear. Now let's go to the memoization. That is a little bit tricky. Let's go to inside analysis. Here I just put some prints. What we have is this is 1, 2, 4 and target is 6. We are gonna say what is printing. Let's say without memoization. Each time I'm printing the candidate and the target. So first we are calling 1, 2, 4, target is 6, then target 5, 4, 3, 2, 1. Okay, now adding 2, 2 minus 6 is gonna be 4. This is so because of this line minus candidate, which is so here I is 1, which is 2. Then we are gonna calculate this one, go up to the end. But here is the issue. Candidate 1, so here when it's calculating this one, it's gonna go back and calculate this one. But we already know that. We had 1 by target 3, we already know what was the answer. It's recalculating it. Here is the thing. So here is so for this example, number of recursion, number that its recursion is occurring, I'm just writing it down. For path counter, it was 33. Even with index, it's the same. Dynamic programming, it's meaningless. It doesn't have, it's not recursive, so it's meaningless. With no path, it's just 21. For some reason, this is less than 33. I don't know why. And then for memoization, it's just 16. Okay, so let's see. So as I said, because here when you saw some stuff has been already calculated that we don't need to calculate. What are we doing here? The same thing. We are gonna have it. The only thing is we added the dictionary. We are still sorting it, and we are gonna go from there. Okay. Here we are gonna get candidate and target. But we also have index j, or j is this I here. So initially j is 0. Same thing as above. If no candidate or target is minus, return. If Okay, each time, okay, just forget about the dictionary for now. We don't need this one again. That's the same shit that we talked about. Okay, we already talked about that. Here, it's gonna send I. Here is the same thing as before. Here, what we save in dictionary. Okay, think about it. What can we send? Here, as you remember, we had 1 and 3, and it was repeated again. So target, we know it should be the same. So one parameter in dictionary that we are saving is the target. What is the other one? What we used to call path. Here it's gonna show up as I, which is or or yeah. The issue with path is maybe it doesn't include everything, but here with I we know it includes one, the first one. So here we are sure it includes one. So when we get to this point here, so here for example, 1, 2, 4, we are gonna go to 1 and then target is 5, 0, 0. We know that we are still in index 0. Now here index got 1 and then we are gonna go for the next round and start from 1 again. So J was 1 here, then J gets 0 again and it's gonna calculate this one. So when it's calculating due, it's recursively. First, it should do it for this one. We already have an answer for that. It doesn't need to search. So it's going to get back here. Above target and J are indexed, so it's going to return. Then 1 and 2, it's going to do 1 for target 1. It's already there. Again, the same. For example, here when J is 2, we can see that here for this one, it says it's there again. So if I print target, if I print dictionary, let me do that. Okay, so temp dic. So you are gonna see the dictionary. Or let me put dictionary. Here is the thing. Let me print dictionary each time. Okay, now it is. So for example here, we are gonna say, or let's see how our dictionary is added. Let me don't print this one. Okay, so first J. Okay, we know the target is 1, J is 0. Target is 1. Okay, then target is 2. Target is 3, J is still 0. It's gonna fill out all of them. And then it's gonna go for, okay, it's gonna add to the J. For example, here 2 and 1. It means the target is 2 and J is 2 and I is 2. So it has, this is why it has 2. And this is how this dictionary is working, and it's how doing the memorization. I think I talked about recurrence, and if I just have large numbers and then comparing all the times for these ones. Okay, I don't know if you can hear my computer sound or not, but okay, just it depends. Because the numbers are random, sometimes it takes 5 seconds, sometimes it takes too much, so I have to stop it like now and rerun it again. Mhm. Here's the thing. If I go with a lower number, okay. So that's the combination. So I'm using the path. As you can see, when we are using index, it's a little bit better. Then dynamic programming is good. recursion with no path is close to dynamic programming. Memoization is much faster than everything. Okay, thank you everyone. Bye.